Okay, we're continuing on now in lesson 6 with example number 2. This is chapter 5, equations in one variable. And we're on example number 2, and we're told to find the length of this rectangle if its area is 3x square units. So let's see, we're going to draw up the rectangle first. And we're going to apply these things that we've been learning about multiplying to get area, adding to get perimeter. In this case, we're going to go with the area. And let me just grab my pen here, and let's put in our values. We have the value here at the top of 5, which means this is 5 as well. And we have x minus 6. And this is x minus 6. Now, we're told that the length, we're told to find the length of the rectangle if the area is equal to 3x square units. So here we're told to find area, which is, we know we multiply one side by the other. So in this case, we'd multiply 5 times x minus 6. Okay. And it's important to remember the difference between area and perimeter. Okay, these are two separate terms. The perimeter is the distance around, and the area is the measurement of the square area, let's say the area within the square or the rectangle, and it's measured in square units. Okay, so whether it's square feet or could be square inches, we've discussed that, square miles. But now we're told that this is equal to 3x, right? Oh, and I just wanted to note here that area is length times width, okay? And perimeter, I'll just write down here, perimeter is 2 times the length, 2L, plus 2 times the width, 2W, okay? So area, this is one and this is the other. We can just cross that out. And in this case, we're dealing with area, so this is what applies. And so we can multiply the length times the width, and we have 5 times x minus 6 in parentheses, and that's equal to the area. And whether the area is on the left or the right, it doesn't really matter. We're going to have to solve this, and we want to solve this for x. So let's go ahead and do our math. We multiply 5 times x to get rid of our parentheses, and 5 times negative 6 is negative 30, and this is all going to be equal to now 3x. Oop, I'm sorry, I put a 30. And now, well, what would we do? Well, we can take the shortcut that we always said. We're going to try to use the simple approach of subtracting from one side so that we don't end up with a negative. So let's subtract 3x from each side over here. And what would we get? Well, we would have 2x minus 30. And you're left with really 0 on this side. Now we would go ahead and add 30 to each side, right? And by adding 30, we move this out, and we're now isolating the x, and we end up with 2x is equal to 30. Now we divide each side by 2, and we will find that the x value is equal to 30 divided by 2, which is 15. Now that we have found the x value, because we know that x is equal to 15, and we have x minus 6, which is now 15 minus 6, that would be equal to 9. All right, x minus 6. So we would actually, I'm sorry there. We would actually run over here and say, well, boy, I'm just drawing all over the place. The artist is coming out from within. We would have 15 minus 6, because that's our x value over here. Okay, we're going to bring that over, and we're going to just plot that in there, and that means that our length, and I guess we're calling this length, and this is the width, okay, that would be equal to 9. So the length of the rectangle, they say, is 9 centimeters. Now, I don't know why they say centimeters, because they haven't really given us any area here, any particular type of unit. So I would have just said 9 units. They didn't really specifically state that. I don't see it anywhere within. We have different examples, but let's just call these things units. And I guess the unit they prefer to use is the centimeter. Now, let's go back over now to lesson number 3. Oh, we can actually substitute. My checking would take me to substitute this 9 value, all right, back into our original equation, and we would see that we would multiply 5 times 9. Okay, that would give us 5 times 9 minus 6, and then we would multiply, I'm sorry, it's not 9, it's x. I'm sorry, we should have put that up here also. And we can multiply 5 times 5 minus 15 minus 6. And so 15 minus 6 is equal to 9. And 5 times 9 is equal to 45. Okay, you can do this math on in your paper and you'll see. And over here on this side we have 3 times 15, which is 45. So it would be 5 times 9, it was equal to 45, and 3 times 15, which is 45. So the 15 did check out. Now let's go over to example number 3, and we're going to do that in 1 second. Okay, I've tidied up our board here so that we can do our next example. And we're told here to find the length of each segment in this diagram if A, B, and C, D are the same length. So we're dealing with lengths here. So I'm going to have to pull out my, let's see, trusty dusty line maker. And we're going to have to make a line that's equivalent. So let's just try to make them as equivalent as possible. All right, now again, one thing that we know here and what they're telling us is that these are equal. And being that they're equal, then we know that we can do certain things with these things, and we can write equations, because whatever this is equal to this. And that's really the key to understanding the words and being able to create equations out of them. So we hear that the length of AB, we have, let's see, we have put the letter A here and B. So AB and CD. Now, what I would do first, I'm sorry, I'm going to finish putting in these values that they have. They have an E, a point E here, and then they give you a value of 10, which is the value of AE. And they give you a value of 2x here, which is the value of EB. Then over here, they give us a value of 4 times x minus 7. So this is a wonderful example. We've got quite a bit of complexity going on already. But what do we know? We know that AB, and we should write it this way, AB is equal to CD, right? That's what they told us. So what is AB? Well, AB is AE plus EB. But we have values here, so we can certainly say AE is 10 plus, and we have EB, which is 2x. So we can write 10 plus 2x to represent AB. And on this side, we have CD of the equation, and we know that CD, they've already given us the value of 4 times parentheses x minus 7. And once we've determined this, now we can simply rely on the things that we've learned in this particular chapter about equations, and we can solve this. And we can see in our book that they solve for x. How do they do it? Well, the first thing they do is they add 2x, or subtract 2x, excuse me, from each side. And so we end up with 10 is equal to 4x. I'm sorry, the first thing they did was they actually distributed. So let's not jump over one step there. They distributed the 4 to the parentheses x minus 7, and they gave us 4x minus 28. Then they proceeded to solve for x with by subtracting 2x from each side, which gave us 10 is equal to 2x minus 28. Then we added 28 to each side to get rid of the minus 28 or the negative 28 value on the right side. And now we're given the expression 38 is equal to 2x. And then lastly, we divided each side by 2, which meant that the x value is 19. But now we simply know the x value. We don't really know the length of each segment. The segments AE, EB, and CD. Well, we do know AE because they tell us it's 10, but x is actually part of the value of EB. So we can plug in the value of 19, and we'll find that when you multiply 2 times x over here, I'm just going to do that down here, 2 times x, which x we learned was 19, okay, that means that EB is 38. Okay, so we know this is 10. Now we know, well, we already knew this was 10, and now we know this is actually 38. But we still don't know this one, so we have to go ahead and do our math again, multiplying, plugging first actually the x value in, and we would have to put in 19 for the x value minus 7. And when we do our math here, we'll find out that 19 minus 7 is equal to 12. 4 times 12 is equal to 48. Okay, I just did it quickly just for the sake of time and simply to show you that we have these values. And that would hold true if you look quite simply by knowing that 10 plus 38 is equal to 48. So we know that. So we can see that these values actually all check. So you were challenged here to apply our knowledge of equations. We create an equation of the AB is equal to CD using that particular step first, and then we broke out. We know that AE plus EB. I could have written that down here. I don't think you really need to do this all the time. In fact, you probably don't even really need to write the first one, but you could see AE plus EB is equal to CD. And so these are just simply segments. Well, what is AE? Well, we put the value of 10. EB is 2x, and CD is 4 times parentheses x minus 7 end parentheses. So once we found our values, we were able to solve this. So now you're going to move on to your exercises, and your exercises are going to challenge you probably as much as you have, or probably more than you have up to this point. There are certain complexities here. And I'm not necessarily going to create a video for this because what we have done in these examples are simply the same examples. They simply become a little more complex. You have to be very careful in adding and subtracting and multiplying, applying the proper rules that you've already learned in the previous lessons, in the previous chapters. So you're going to, in the first set number 2, you need to find an expression for the perimeter. Remember, P is equal to what? All of the sides added. So you add all the sides up. But you don't just leave it. You need to simplify. I don't want to see P is equal to x plus 1 plus x plus 4 plus x plus 3 plus x plus 2. Well, now you need to add up all your x's. You need to add up all your numbers and give me an answer at least in the form of a simplified form, such as 5x plus, in this case it probably would have been 5x plus 10, I believe the answer would have been there. So I don't want to see just a bunch of x's being added. You need to simplify, always simplify. Now, we're to find an expression for the area of each of these rectangles. So again, do your math, multiply. In the last one we see an 8 and we see an x minus 4. Okay, this is in problem number 5, letter C. Don't just give me 8 times parentheses x minus 4. You should multiply that out, and the answer would have been 8x minus 32. Now, they're giving us in number 6 the perimeter. The perimeter is 19. Now we need to write an equation and solve to find the lengths of each of the triangle sides. So we would add all these together, and that would be equal to the 19 number that they gave us to the perimeter. Do your math, solve for x. And then once you have the x value, you need to plug it back into your original length. So if you have an x value, x plus 2, well, what's the x value? Plug it in and tell me what each actual side is equal to. Now we're going to apply that the method that you used in exercise 6 to find the lengths of the sides of the following if we know their perimeters. Okay, we have here perimeters equal to 26, 16. And again, you're going to be doing set 3, but I'm just kind of going over the methodology here. Number 8 is very similar, but remember we're doing area, and be very careful. How do we find perimeter? We add all of the sides. How do we find area? We multiply the length times the width. Okay, and then lastly, number 9, we have these segments, and the segments that we did in example number 3, which is right in front of you. Similarly, we're going to determine and find the length of each segment, okay, because you know that, for instance, A and B is, or AB is equal to CD, so now you need to use the information that's given, and by creating an equation saying whatever's in AB is equal to CD, you can then solve for X. So again, if you have any questions, any problems, feel free to raise your electronic hand and send me an email.